Most organizations think they're rolling out Copilot. They're not. They're switching from deterministic SaaS, where you can diagram cause and effect, to probabilistic orchestration, where behavior emerges at runtime and drifts quietly. This episode gives you a post-SaaS mental model, 3 Microsoft scenarios you'll recognize immediately, and 1 metric that exposes the real risk, mean time to explain. If you're responsible for Microsoft 365, Power Platform, or Azure AI, subscribe, because agent sprawl isn't coming, it's already here. Now, the foundational misunderstanding. The foundational misunderstanding. AI as a feature, not an operating model. The most comforting story in enterprise IT right now is that AI is a feature, a checkbox, a license, a rollout plan, a change advisory board item, something you enable the same way you enabled Exchange Online, Teams, or E5 security. People want it to fit inside the existing SaaS operating model because that model is familiar. You provision accounts, assign permissions, configure policies, publish guidance, and then the system mostly behaves the same way tomorrow as it behaved today. That model worked because SaaS, for all its flaws, is still largely deterministic. Deterministic doesn't mean perfect, it means legible. It means state transitions are predictable enough that architects can draw boundaries, auditors can map controls, and operators can build runbooks that assume the platform will execute what it was configured to execute. When SaaS fails, it tends to fail like a machine. Outages, throttling, expired certificates, broken dependencies, bad deployments. Ugly, but explainable. AI doesn't land as a feature inside that world. It lands as a new execution layer that sits inside every workload you already run. And the moment that execution layer makes decisions at runtime, your old assumptions start decaying, not because Microsoft broke something, because you moved from configuration-driven execution to interpretation-driven execution. That distinction matters. In deterministic SaaS, the workflow is defined at design time. Someone models a process, writes a flow, builds a form, configures a connector, assigns a role. When a user clicks the button, the system executes the path you already defined. You can be wrong, but you're wrong in a stable way. In agentic systems, the workflow is assembled at runtime. The system doesn't just execute. It decides what to execute based on intent, context, tool availability, and whatever memory or grounding you've allowed it to access. It chooses a path. It chooses a tool. It chooses a source. And if you think that choice is just the model, you miss the point. The choice is the product of an orchestration stack: prompts, policies, plugins, connectors, permissions, retrieval, ranking, and the user's environment. That stack becomes your new runtime. So when leaders ask for the Copilot rollout plan, what they're actually asking without realizing it is, how do we deploy a distributed decision engine into our organization without changing how we control decisions? They're asking for a plan that preserves the old contract, user to app. User to app is the SaaS era contract. The user initiates, the app executes. Identity and access management is built around that. A human principal signs in, gets a token, performs an action inside a bounded app surface. The blast radius is mostly the app plus the permissions you granted. Post-SaaS breaks that contract. The new contract is intent to orchestration. The user expresses intent, the orchestration layer interprets it, and then delegates execution across tools, sometimes across multiple tools, using authorities that are often broader than the user understands. The user doesn't use SharePoint. The user expresses find the doc, summarize it, send the action items, and the orchestration layer touches SharePoint, Outlook, Teams, maybe a Power Automate flow, maybe a connector, maybe an external system. That's not user to app, that's intent to toolchain, and it's not optional. This is the uncomfortable truth. Once you introduce agents, you are no longer running a set of SaaS services. You are running an orchestration fabric. The SaaS services become tool endpoints inside that fabric. The UI becomes a conversational interface, and the workflow becomes a probabilistic plan assembled on demand. This is why so many organizations feel like they're making progress, but their architecture feels less stable every quarter. They treat AI like an add-on, but it behaves like an operating model shift. They stand up adoption training and call it done, but the system changes where decisions get made. They add a few guardrails, but guardrails don't define contracts. They create approved prompts, but prompts are not controls. They are suggestions to a reasoning system that is optimized to be helpful, not obedient. Here's what most people miss. The real scaling event isn't that more people will use Copilot. The real scaling event is that you're introducing non-human actors, agents that will perform actions, chain actions, and delegate actions, and those actions will be shaped by a constantly changing environment. New connectors, updated models, revised prompts, shifting data quality, changing permissions, and drift in the information estate. That means your system can have the same configuration and still produce different outcomes week to week. That's not a bug. That's probabilistic execution. So the foundational misunderstanding is simple. If you approach AI as a feature, you'll keep applying SaaS-era controls to a post-SaaS runtime. You'll measure adoption, not behavior. You'll inventory licenses, not decision pathways. You'll ask, is it enabled, not is it legible? And the consequence is predictable. You won't get simplification, you'll get acceleration, and the architecture won't visibly collapse. It'll just stop matching reality. Now define what post-SaaS actually means without the futurist nonsense. What post-SaaS actually means in enterprise architecture. Post-SaaS doesn't mean SaaS is dead. It means SaaS stopped being the place where work completes. In the SaaS era, enterprise architecture leaned on a stable contract, a user interface, an API surface, and predictable state transitions. You could argue about quality, uptime, licensing, or integration pain, but the shape of the system was consistent. A request came in, the platform executed a defined operation, and a record changed state. Operators could observe it, architects could bound it, auditors could test it. That contract is what made service ownership work. Teams owned Exchange, SharePoint, Teams, Dynamics, whatever, because the workload boundary roughly matched where execution happened. When something went wrong, you knew where to look. It might take time, but the system gave you a finite set of places to interrogate. Logs, policies, permissions, connectors, runbooks. Post-SaaS is what happens when you add a probabilistic overlay that sits above those contracts and starts interpreting intent instead of executing commands. That overlay has 4 parts that matter architecturally: prompts, tools, memory, and delegation. Prompts are not user input. They're runtime policy. They shape behavior, they constrain scope, and they change faster than change management can track. Tools are not integrations, they're executable capabilities, connectors, plugins, graph calls, flows, APIs. Memory isn't just chat history, it's what the system can remember, retrieve, and treat as context, across sessions, across users, across time. Delegation is the quiet multiplier. One agent hands work to another agent, which calls another tool, which triggers another workflow. So the system you thought was Microsoft 365 plus some automations becomes a distributed orchestration fabric that assembles execution paths on demand. Here's where the contract breaks. In SaaS, the boundary lives at the API. If the API call happened, you can trace it. If a permission allowed it, you can justify it. If an audit log recorded it, you can defend it. The system is still deterministic enough that what happened and why it happened are linked. In post-SaaS, interpretation replaces execution as the dominant mechanism. The agent doesn't just call create event. It decides whether the user meant schedule, draft, delegate, or summarize, then chooses which tools to invoke, in what order, with what parameters, based on context that is not visible to the user and often not visible to the operator. The output looks like a single experience. The reality is a toolchain. That distinction matters because architecture is fundamentally about controlling side effects. In deterministic systems, side effects come from explicit calls. In probabilistic systems, side effects come from implicit plans. And you don't control implicit plans with documentation. You control them with contracts and boundaries the orchestration layer can't casually step over. This is why more automation is the wrong frame. Automation assumes you're codifying a known sequence. You design it, you test it, you deploy it. If it breaks in the same place until you fix it. Post-SaaS systems don't just run sequences, they synthesize them. 2 users ask the same thing, and the system takes 2 different paths because context differs, tool availability differs, permissions differ, or the model selection differs. You get different execution, not because you changed configuration, but because the runtime interpreted the intent differently. So post-SaaS is a new control surface. The control plane is no longer only policies, roles, and settings inside each SaaS workload. It becomes the orchestration layer. What tools exist, who can use them, how identity is represented to tools, what context is allowed, how memory persists, how delegation is constrained, and what gets logged in a way humans can reconstruct. And it's not theoretical. Microsoft is building toward this with agent runtimes across M365, agent building in Copilot Studio, and orchestration stacks in Azure AI Foundry. The details change. The architectural behavior does not. Once an enterprise allows intent to orchestration at scale, the architecture stops being a diagram of apps and services. It becomes a graph of decision pathways. And if you don't model that graph explicitly, you don't have a post-SaaS strategy. You have a collection of probabilistic behaviors that only look coherent because the UI hides the wiring. Now the paradox, the more intelligence you add, the faster that wiring fragments. The post-SaaS paradox. Intelligence accelerates fragmentation. The promise of agents is consolidation. One interface, one copilot, one place to ask, handle this, and have the platform stitch the work together across SharePoint, Teams, Outlook, Power Platform, and whatever else you connected. Leadership hears that and thinks, fewer apps, fewer processes, fewer tickets, fewer people needed to babysit the mess. They're not wrong about the intent. They're wrong about the system behavior. Because intelligence doesn't remove complexity, it redistributes it. And when you redistribute complexity into runtime decisions, fragmentation stops being an accident. It becomes the default outcome. Here's what most people miss. SaaS-era fragmentation was mostly structural. Too many apps, too many sites, too many teams, too many connectors. You could see it, you could inventory it, you could produce a depressing spreadsheet and pretend that was control. Agent-era fragmentation is behavioral, and behavior fragments faster than configuration ever did. Why? Because every team optimizes locally, always. Sales tunes Copilot prompts for pipeline updates, legal tunes it for contract analysis, finance tunes it for reconciliation, HR tunes it for onboarding. Each group adds just one more plugin, just one more connector, just one more exception, until the orchestration layer stops representing an enterprise and starts representing a set of departments with incompatible assumptions. Local optimization creates global incoherence. That's the paradox. The more useful the agent becomes for each team, the less consistent the overall system becomes. And it doesn't look like fragmentation in the UI. It looks like Copilot working. Until someone crosses a boundary and discovers the agent they thought was a shared capability is actually a dozen different runtimes with a dozen different toolchains. This is where standardization becomes an endless chase. Organizations respond the same way they always do. They write guidance. They publish a prompt library. They declare approved plugins. They create a governance page, they schedule a quarterly review, and then the system keeps drifting anyway, because the drift isn't coming from a missing policy document. It's coming from the runtime itself. A model update changes tool selection patterns. A connector update changes what data is reachable. A new Teams feature changes the context surface. A user discovers a better phrasing and shares it in a chat. A maker copies a flow and tweaks one step. Nothing big changed, but outcomes diverged. That's not configuration drift, that's behavior drift. And behavior drift beats configuration drift because you can't diff it the way you diff settings. You can't audit it the way you audit roles. You can't test it once and assume stability for 6 months. The system makes new decisions every time it runs. So the paradox becomes operationally visible in a very specific way. Incidents shift from the system is down to the system behaved wrong. Nobody gets an outage banner. Nothing is throttled. The service health page is green. But a team swears Copilot used to find the right policy doc and now it cites the wrong one. Or an agent used to summarize a meeting accurately and now it pulls in irrelevant context. Or a flow used to create one record and now it creates duplicates. Or the agent helpfully emailed a draft to the wrong distribution list because the runtime chose a different toolpath than last week. That's a different class of failure. And it's worse for leaders because it turns control into probability. The platform isn't broken. Your assumptions are. This might seem backwards, but the more intelligence you add, the more you multiply the number of possible execution paths. Every tool you attach is another branch in the decision graph. Every memory source is another influence. Every delegated agent is another interpreter. The system becomes a branching tree of could-do options. And you no longer control which branch gets taken by setting a policy in one admin center. You control it by designing boundaries the runtime can't violate. Without those boundaries, standardization becomes theater. You will be rolling out Copilot forever because every new use case creates a new local optimum. Every local optimum becomes another divergence. And over time, the enterprise stops having an architecture. It has a collection of probabilistic behaviors that sometimes align. The real enemy isn't that teams move too fast. The real enemy is that nobody defined what must remain deterministic. So intelligence accelerates fragmentation because it turns execution into choice. And choice always follows incentives, not diagrams. And incentives are local. Now name the thing that's actually happening. Not disorder, not sprawl, not governance gaps. Entropy. Architectural entropy, not disorder but unmanaged decision pathways. Entropy gets used like an insult, like it means messy, uncontrolled. People aren't following the process. And that's not what's happening. Architectural entropy is not disorder. It's the accumulation of unmanaged decision pathways that produce side effects you didn't model, didn't approve, and can't reliably trace after the fact. In the SaaS era, the dominant pathways were predictable. A user clicked in a UI, an API call executed, a record changed state. You could argue about who should have had access or whether the process was designed well, but the pathway itself was visible. It left a trail you could follow because the system ran what you configured. In post-SaaS systems, pathways multiply at runtime. An agent interprets intent, selects tools, pulls context, chooses an action sequence, and sometimes delegates. That creates a decision graph that is wider than your documentation and faster than your review cycles. And every time you add one more connector, one more plugin, one more helpful automation, you add branches to that graph. That's entropy. More branches, more side effects, less certainty. Here's the uncomfortable truth. Most organizations are still trying to manage entropy like it's configuration drift. They look for the settings that changed. They hunt for the toggle that flipped. They ask who modified the policy. And sometimes that's valid. But the new failure mode isn't a setting changing. It's a pathway becoming possible. Once a pathway exists, it will eventually be used. Not maliciously, not even intentionally, just because the system optimizes for completion. And humans optimize for it worked once, so ship it. Those pathways accumulate, and they don't show up in your architecture diagrams because diagrams describe designed flows. Agents create executed flows. That distinction matters. Deterministic systems fail like machines. They fail loudly. Outages, errors, timeouts, authentication breaks. You get MTTR because you can point at a component and say, this thing failed. Probabilistic systems fail like organizations. They fail ambiguously. Nothing is down, but the outcome is wrong. The system did something, and now you're arguing about whether it was a bug, a misinterpretation, a permissions edge, a context issue, or a prompt drift problem. That's not MTTR, that's a debate. And the debate is the cost. This is why exceptions are entropy generators. In the SaaS era, exceptions were already dangerous, but they were usually bounded. A specific mailbox gets a transport rule exception, a specific group gets an access exception, a specific site gets an external sharing exception. It's bad, but at least it's a stable bad. In the agent era, exceptions don't stay local. A just this once connector approval becomes a reusable capability. A temporary graph permission becomes a new normal. A prompt tweak becomes a copied template. A flow fork becomes a pattern. An environment created for testing becomes the place where production runs because it worked. These aren't accidents. They're how systems behave when intent is not enforced by design. So entropy isn't the absence of governance. It's the absence of boundaries that make your assumptions true. And the cost shows up in 3 places leaders actually feel. First, change slows down. Not because teams are lazy, because nobody knows what a change will break anymore. When execution is probabilistic and tool chains are implicit, every change becomes a risk to pathways you didn't know existed. So teams add reviews, then add more reviews, then add manual approvals, and eventually velocity collapses, entropy taxes speed. Second, incident ambiguity explodes. Your best engineers spend their time reconstructing what the system saw, what it decided, and what it did. The work turns into forensic analysis of tool calls, context selection, memory retrieval, and delegation chains. You're not fixing a broken server, you're reconstructing a decision. Third, invisible dependencies multiply. In deterministic SaaS, dependencies are mostly explicit. This app calls that API, this workflow triggers that service. In post-SaaS, dependencies become conditional. The agent might call this tool if it interprets the request that way, but it might not. So you can't map dependencies as a static graph. You inherit a probabilistic one. And that is exactly how architectural erosion happens. Not with a single catastrophic failure, with 1,000 small pathways nobody owned. So when people say AI is making things messy, the correction is simple. AI is making decision pathways cheap, and anything cheap gets overproduced. The fix doesn't start with a new admin center. It starts with making those pathways measurable, because what can't be measured will be explained away as user error until it becomes systemic. The next section is the metric leaders keep ignoring. Mean time to explain. The metric leaders ignore. Mean time to explain, MTTE. MTTR is the metric everyone knows because MTTR fits deterministic failure. Something breaks, you identify the component, you restore service, you close the ticket. MTTR assumes the question is, how fast can we fix it? Because the system already told you what it is. Post-SaaS breaks that assumption. The new bottleneck is not fixing, it's explaining. Mean time to explain is the time it takes your best people to answer a single, humiliating question. Why did the system do that? Not why did it fail? Why did it behave that way? MTTE shows up the moment your incident narrative stops being technical and becomes interpretive. The service health page is green. Authentication works. No CPU spikes. No obvious outage. But the output is wrong or inconsistent or risky or just different. And now you're not restoring service. You're reconstructing intent, context, and delegation across a toolchain that nobody can see in one place. This is the part executives underestimate because it looks like soft work. It isn't. MTTE is the cost of operating a distributed decision engine without deterministic boundaries. And it grows with every new tool, every new connector, every new prompt variant, and every new small automation that becomes part of the runtime. Here's what drives MTTE in practice. First, tool calls. An agent doesn't just answer, it calls tools, graph, connectors, flows, external APIs, sometimes multiple tools in a chain. If you can't see the tool sequence and the parameters used, you can't explain the outcome. You can only guess. Guessing is not an incident response strategy. It's a career hazard. Second, delegated actions. An agent that delegates to another agent creates a second decision boundary. The parent agent made a choice to delegate. The child agent made a choice about execution. And now you have at least 2 sets of instructions, 2 context windows, and potentially 2 different tool catalogs. That delegation chain is an entropy multiplier because it fragments accountability. Everyone will claim their piece worked as designed because nobody owns the behavior of the whole. Third, hidden grounding. In M365 land, grounding is often whatever the system could see, which sounds safe until you remember visibility is not intent. If Copilot pulled in a document, a chat thread, or a meeting transcript the user didn't expect, the output can drift without any configuration change. And when you investigate, you realize your logs can tell you something accessed SharePoint, but not what the model selected as relevant or why it ranked one source above another. That gap is MTTE. Fourth, prompt and version drift. In the SaaS era, you tracked configuration versions and release notes. In the agent era, prompts are runtime logic and they drift like folk knowledge. A better prompt gets shared. Someone forks an agent, a maker tweaks instructions. A model update shifts how the same prompt is interpreted. Now, the organization has multiple behavioral versions of what everyone thinks is the same Copilot. And when something goes wrong, the hardest part is just finding which version of the instructions produced the output. So MTTE is not a new KPI for the sake of novelty. It's the board-relevant risk metric for agentic systems. Because audits don't care that you have logging. Audits care that you can explain a decision path. If your best answer is the model decided, you don't have auditability. You have theater with timestamps. And MTTE connects directly to velocity, variety, and volume, the forces that Harbridge points at, but most leaders treat like adoption trivia. Velocity compresses change cycles until your explanations lag behind reality. Variety multiplies the number of possible runtimes that could have produced the behavior. Volume increases the count of autonomous decisions per day until we'll look into it becomes the default state of operations. This is why MTTE matters more than MTTR. MTTR tells you how fast you can recover a system you understand. MTT tells you how often you operate a system you don't. And once MTTE crosses a threshold, your architecture stops scaling. Not because compute is expensive, but because explanation is. At that point, you can still deploy more agents. The platform will let you. You just won't be able to defend what they did or prove why they did it or predict what they'll do next. And that's the moment the enterprise realizes it didn't buy automation. It bought ambiguity at scale. Now take that metric and apply it to the first accelerant, velocity, because AI compresses change cycles until governance, review, and even architecture language can't keep up. Velocity, AI compresses change cycles until governance becomes irrelevant. Velocity is the first accelerant because it attacks the one thing enterprise IT relies on to stay sane, time. In the SaaS era, change had friction. Product teams shipped monthly. Enterprises reviewed quarterly. Security did annual attestations and called it continuous improvement. Nobody loved that cadence, but it matched reality. Configuration changed slower than people's ability to understand it. AI breaks that, not because it ships faster, because it behaves faster. Harbridge frames velocity as the pace of technology change, and he's right, but most leaders still translate that into feature velocity, new buttons in Teams, a new Copilot pane, a new admin setting. That's manageable. Annoying but manageable. Agent velocity is behavioral velocity. It's how quickly the system's decision patterns shift, even when you didn't approve a change. A model update changes how intent is classified. A retrieval change changes what gets grounded. A connector change changes what tools are available. A new prompt pattern goes viral inside one department and becomes de facto runtime policy by lunchtime. The system is not waiting for your change window. It's evolving while you're still writing the risk assessment. This is the uncomfortable truth. Your control plane lags behind your execution plane, and the gap is where entropy grows. Look at what happens in Microsoft ecosystems specifically. A Copilot experience lands in one workload, then another. A preview becomes GA. A plugin gets introduced. Copilot Studio expands capability. Azure AI Foundry adds orchestration features like connected agents or workflow patterns. Meanwhile, teams are iterating prompts and automations daily because the cost of iteration is basically zero. So policy review cadences stop being governance. They become archaeology. By the time a committee meets to decide whether a connector is approved, someone already used it, wrapped it in a flow, embedded it in an agent, and shipped it as just a productivity helper. The decision got made at runtime. After the fact, you can argue about it. The system already executed it. This is why will govern after the pilot is such a reliable failure pattern. In deterministic systems, pilots are bounded. A subset of users, a subset of capabilities, a stable set of controls. In agentic systems, pilots leak. People copy what works. Templates spread. A single agent becomes 20 forks. A single good prompt becomes a library of variations. And because the experience is conversational, people don't treat it like code. They treat it like advice. But it runs like code. That mismatch is exactly where velocity turns into risk. And here's the part leaders hate hearing. Citizen builders are not the problem. They are the delivery mechanism. Power Platform, Copilot Studio, and reusable templates are accelerants that compress the time between intent and execution. That's the point. The platform is designed to reduce friction. And friction is what used to protect the enterprise from itself. So when velocity spikes, the enterprise doesn't just ship more. It revises reality more often. And when reality revises faster than architecture can be explained, MTTE explodes. Your operators spend their time answering, why did it do that? Instead of improving the system, because that keeps changing. And this also changes how security debt behaves. In the SaaS era, security debt was mostly dormant until something poked it, an audit, a breach, a migration. In the agent era, security debt becomes active fuel. Old oversharing in SharePoint isn't just an ugly legacy problem, it becomes immediate model context. Old guest access isn't just a risk, it becomes an action pathway. Old orphaned groups aren't just clutter, they become permission edges an agent can traverse if it's allowed to. Velocity doesn't create the debt, it monetizes it. And because velocity compresses the feedback loop, organizations start responding with the wrong tool. More meetings, more approvals, more checklists, more governance. That doesn't slow the runtime. It just slows the humans. The system keeps executing. The organization becomes the bottleneck. So the practical definition of velocity in post-SaaS is simple. It's the rate at which behavior changes relative to your ability to explain it. Once that ratio breaks, governance becomes irrelevant in the literal sense. Not important, but unable to influence outcomes before they occur. And that's why velocity never arrives alone. It immediately collides with the second accelerant, variety. Because once the platform can change this fast, it also changes in more ways than your architecture language can keep up with. Variety. Agent experiences multiply faster than your architecture language. Variety is where leaders lose the plot because it doesn't look like risk. It looks like options. One Copilot experience in Teams, another in Outlook, a Copilot pane in SharePoint, a declarative agent someone made in 5 minutes, a custom engine agent built by a dev team, a Power Automate flow that just calls AI once, a plugin, a connector, a tool, a memory store, a retrieval system, a model switch. All of that feels like the ecosystem getting richer. Architecturally, it's the ecosystem getting less coherent. Because variety isn't just more ways to build, it's more runtimes, more context surfaces, more tool catalogs, more execution semantics, and every runtime behaves slightly differently. Even when the branding is identical and the user thinks they're talking to Copilot, that distinction matters. In the SaaS era, you could build an architecture language around workloads. Exchange behaves like Exchange. SharePoint behaves like SharePoint. Teams behaves like Teams. You could argue about integration, but you could still model boundaries because the execution semantics were stable enough. In the agent era, those boundaries blur because the work stops happening inside the app and starts happening across a toolchain. Now, the same user intent, summarize this, draft that, find the policy, notify the group, can land in different orchestration stacks depending on where the user asked. Teams has one context surface. Chats, channels, meetings, transcripts. Outlook has another. Mail threads, calendars, attachments, mailboxes. SharePoint has another. Sites, pages, libraries, permissions, metadata. Even if the model is shared, the retrieval and grounding pathways aren't. So the enterprise ends up with one Copilot that behaves like 3, 5, or 10. This is the hidden variety. It isn't the UX, it's the toolchain and the reasoning pattern behind the UX. And it multiplies in 2 ways at once. First, the visible variety, which Microsoft will happily ship. Copilot UX in multiple apps, declarative agents in Copilot Studio, custom engine agents via Procode toolkits, Azure AI Foundry orchestration patterns like connected agents and multi-agent workflows, MCP servers exposing tools, agent-to-agent delegation, different model options, different grounding approaches. None of this is inherently bad. The system is behaving like a platform, but a platform doesn't give you one standard way to operate. It gives you a menu, and enterprises are terrible at menus. They select based on local pain, local skills, and local deadlines. Then they call it strategy. Second, the invisible variety, which enterprises create for themselves. Different teams build different tool chains. One group relies on SharePoint as a knowledge base. Another relies on OneNote. Another relies on Teams messages. Another relies on PDFs in random libraries. One team builds a flow that writes to Dataverse. Another team writes to a spreadsheet. Another team sends an email. Another team posts into a Teams channel. Same business intent. 4 different execution paths. 4 different side effects. 4 different failure modes. And now the same policy doesn't create the same posture. This is where security teams get blindsided. They assume that if conditional access, DLP labels, and access reviews are central, then the agent experience is centrally controlled. That was true when the application boundary was the control surface. In post-SaaS, the control surface is the orchestration layer. What tools are reachable, what context is selectable, what memory is persistent, what delegation is allowed, and what identity is presented to the tools. So even with central policies, variety creates inconsistent outcomes. One agent uses a connector with delegated permissions that quietly exceeds what the user thinks they authorized. Another agent uses a different connector that fails and falls back to a different data source. One runtime strips citations, another keeps them. One runtime can act, another can only suggest. One runtime logs tool calls in a way you can trace. Another leaves you with conversational smoke. Same organization, same intent, different behavior. And because the variety is distributed across tools, builders, and teams, your architecture language can't keep up. Your diagrams still show apps and services. The system is actually a shifting set of agent runtimes and tool chains. You're describing a deterministic world while operating a probabilistic one. That mismatch is why incidents feel surreal. Operators aren't asking which service failed. They're asking which runtime did this user hit, with which context, with which tool catalog, with which prompt version, and which permission edge. That's MTTE getting paid in full. And variety is also the bridge to the final accelerant, because once you have many runtimes, you inevitably get many instances. Variety becomes volume the moment those experiences scale beyond a handful of pilots and become the default way work gets done. Volume. The agent-to-human ratio quietly explodes. Volume is the part leaders think they understand because they've lived through volume for 20 years. More mailboxes, more teams, more SharePoint sites, more documents, more groups, more apps, more logs, more tickets. Volume felt like a storage and operations problem, so enterprises built inventory thinking, count the things, classify the things, put policies on the things, then try to slow the rate at which new things appear. That logic collapses in the agent era because volume isn't primarily artifacts, it's decisions. The real scaling event is not that you'll have a lot of agents, it's that you'll have a lot of autonomous decision points firing all day across thousands of users, and those decisions will create side effects in systems of record. Calendar entries, emails, records in Dataverse, permissions changes, tickets, notifications, file copies, labels, shares, links. And unlike SaaS-era volume, you don't get one decision per click, you get chains. A single user intent becomes multiple tool calls, and each tool call becomes a potential fork. Retries, fallbacks, alternate sources, delegated sub-agents, and compensating actions when something partially succeeds. That means the number that matters isn't agents per tenant, it's autonomous actions per day. This is why the agent-to-human ratio is such a useful mental model. The ratio is never stable, it always grows, because once an organization has one working agent pattern, it gets copied, templated, and embedded into workflows until the default expectation becomes the agent handles it. Humans only review the exceptions. That's fine, right up until you realize the ratio also drives blast radius. Every additional agent doesn't just add another capability, it adds another execution pathway that can touch data, trigger workflows, and create side effects. And those pathways don't exist in isolation. They share tool catalogs, they share connectors, they share permissions, they share data stores. So the marginal risk of one more agent isn't one more thing to manage. It's more load on the same brittle graph. Here's where inventory thinking fails. Counting agents doesn't tell you anything about their authority. A declarative agent that can only retrieve and summarize content behaves like a read-only reporting surface. It can still leak information, but it can't mutate systems. A task agent that can send mail, create records, or trigger flows is a different class of risk. A decision agent that can choose actions without human review is a different class again. So if leadership asks, how many agents do we have? The only accurate answer is that's the wrong question. The right question is, how many autonomous decisions can execute side effects, and where are those decisions allowed to land? Volume also creates a specific sprawl pattern that looks harmless until it becomes permanent. Duplicated agents, forked prompts, orphaned flows, environment drift. Someone copies an agent because it's faster than requesting access. Someone forks a prompt because it's just wordings, and someone creates a new connector because the approved one is slow. Someone builds a flow in a personal environment because they're testing, then the test becomes production because it works. Those are not exceptions. Those are entropy factories. And volume turns them into normal operations. This is where MTTE becomes a certainty, not a risk. Because the more autonomous decisions you have, the more often you'll need to explain one. And the explanation burden doesn't scale linearly. It scales with the number of possible pathways, the number of runtime versions, and the number of implicit dependencies. So the enterprise does what it always does. It tries to centralize visibility after the fact. A registry, a dashboard, a report, a monthly review of top agents. That can help, but only if it's tied to contracts. Otherwise, it becomes another spreadsheet of comfort, because volume isn't the enemy, unbounded volume is. And unbounded volume is what happens when organizations treat agents as helpers instead of products. Products have owners, products have versions, products have deprecation, products have telemetry that answers uncomfortable questions. Helpers have enthusiasm, templates, and no life cycle. Over time, the agent workforce becomes the dominant workforce, not in headcount, but in executed actions. And once that happens, every weakness in identity, permissions, data quality, and observability gets amplified by automation. The system doesn't just scale outcomes, it scales mistakes. That's the point where leaders finally feel the paradox in their calendar. Nothing is down, but everything takes longer to trust. Now shift from theory to the first scenario everyone recognizes. We rolled out Copilot. Scenario 1 setup. We rolled out Copilot. This is the story every Microsoft leader tells right now because it sounds responsible. We rolled out Copilot. Translation: procurement bought the licenses, someone flipped the toggles, there was a readiness checklist, a couple of pilot teams, some prompt training, maybe a security review, and then a launch email with a SharePoint page full of cheerful guidance. If they're more mature, they also turned on some reporting and created a channel where users can share great prompts. And then leadership expects the return. Fewer hours lost in email, better meeting follow-ups, less time searching for documents, faster drafting, faster analysis, less friction, the usual narrative of productivity gain. And to be clear, some of that is real. But the rollout framing is the trap, because Copilot is not an app you deployed into a clean environment, it's an orchestrator you deployed on top of your existing information estate. And that estate is not tidy. It never was. It's a decade of SharePoint permissions that drifted, teams that proliferated, sites nobody owns anymore, documents with unclear lineage, retention policies that got applied unevenly, and a pile of temporary access that became permanent during the pandemic and was never revisited. Copilot doesn't create that mess, it simply makes it executable. Here's what most organizations miss in the first 90 days. The first order effect isn't users got faster. The first order effect is that teams learn which context surfaces Copilot can see, which it can't, and which it can be coaxed into seeing through workarounds. They learn which prompts reliably produce useful outputs. They learn which plugins or connectors unlock the missing capability. They learn which data sources are too noisy, so they route around them. That learning becomes behavior, and behavior becomes a local standard. So the first thing that diverges is enablement, not the formal enablement, the real one. One business unit runs internal prompt clinics. Another shares prompts in a Teams chat. Another builds a private prompt library in OneNote. Another hires a consultant who hands them a pack of templates. Another quietly decides Copilot is unreliable and stops using it, except for drafting emails, because that's safe. Now, you don't have one Copilot rollout, you have multiple Copilot cultures. And that cultural drift turns into technical drift faster than most architects expect, because Copilot's value rises with reach. The moment a team hits the limit of what basic Copilot can do, they don't file a request for a new application. They attach a capability, a plugin, a connector, a graph permission, a Copilot Studio action, a Power Automate flow that just helps Copilot by doing the last mile, a shortcut that creates a side effect without making the side effect visible. And those attachments don't happen centrally. They happen where pain exists, locally, under time pressure, with good intentions. This is where we rolled out Copilot becomes structurally false, because you didn't roll out a single thing. You rolled out an orchestration layer that behaves differently depending on the workload and the team. Teams becomes one runtime. It has meetings, transcripts, chats, channels, and a social graph that changes by the hour. Outlook becomes another runtime. Mail threads, calendar context, attachments, and delegated mailboxes. SharePoint becomes another runtime. Site permissions, library structures, metadata, link sharing patterns, and an information architecture that mostly exists in someone's head from 2019. So when an exec says Copilot couldn't find the policy, that sentence is meaningless. Which Copilot surface, in which app, grounded on which sources, under which permissions, with which connectors enabled, with what chat history, in which tenant configuration, after which recent model update? The platform isn't one thing. It's a set of agent runtimes with a shared brand, and then the sprawl starts to look helpful. It always does at first. A department creates an approved prompt list. Someone builds an HR Copilot helper that points at their SharePoint. Someone builds a sales follow-up agent that drafts emails and updates a CRM through a connector. Someone creates a Teams tab with a custom Copilot experience. It's all incremental. Nothing feels like architecture until you try to explain why the same question yields different answers for different users, or why Copilot cited a document someone insists they don't have access to because the permission edge is real even if nobody remembers granting it, or why a summary changed week to week even though nothing changed, because the context surface did. This is the setup. Copilot didn't simplify your tenant. It turned your tenant into the runtime. And the moment the tenant becomes the runtime, you are no longer managing a product rollout. You are managing an emerging behavior system with side effects. Scenario 1, entropy signals. Copilot across M365 becomes micro-agent divergence. Entropy signals in Copilot aren't dramatic. They're boring. That's why they get ignored until they stack into operational pain. The first signal is that SharePoint, Teams, and Outlook are not three front ends. They are three different agent runtimes with three different context surfaces and three different default assumptions about what matters. Teams is conversation first. Outlook is thread first. SharePoint is content first. The same prompt lands on different grounding, different retrieval, and different relevance ranking depending on where the user asked. So Copilot gave a different answer isn't user error, it's runtime variance. And once leadership hears variance, they do what they always do. They standardize. So the second signal is the prompt library. Every organization ends up creating one. Sometimes it's official, sometimes it's folklore, sometimes it's a Teams channel with screenshots. Either way, it becomes a comforting artifact because it feels like policy. But prompts aren't controls. They don't enforce boundaries. They're input to a reasoning system that can interpret, skip, or reframe them based on context. What this actually looks like in the wild is simple. Someone says, use the approved prompt, and the response improves for that user in that app, for that data set this week. Then another team copies it, tweaks 3 words, adds be concise, adds act as A, and now you have prompt drift. Not because people are reckless, because prompts are the easiest thing in the stack to edit, and editing feels harmless. But prompt edits are runtime logic changes. You're changing the decision surface, not the documentation. The third signal is permission edges. Copilot rides Microsoft Graph. And Graph is not a single permission boundary. It's an authorization graph that's shaped by groups, sites, sharing links, delegated mailboxes, sensitivity labels, and all the historical decisions nobody revisited. So you get the same intent producing different access outcomes. One user gets the right answer because they're in the right group. Another user gets a weaker answer because they're not. And a third user gets a dangerously confident answer because they have access through a link-based permission that no one remembers granting. That's the core post-SaaS issue. Authorization is still deterministic, but the user experience becomes probabilistic. So you get the weird incident class where nobody can tell if the problem is Copilot, permissions, or content hygiene, because all 3 are now coupled in the output. The fourth signal is connector and plugin divergence. Even when the enterprise thinks it enabled Copilot, the real Copilot experience becomes defined by what extra capabilities teams attach. Some teams allow more plugins, some block them, some discover third-party connectors, some build Copilot Studio actions. Each choice expands the tool catalog. And expanding the tool catalog expands the decision pathways. That's not a governance point. It's mechanical. More tools means more branches. Over time, Copilot stops being a single capability. It becomes a family of micro-agents. One inside Teams with meeting context, one inside Outlook with mailbox context, one inside SharePoint with library context, plus a handful of departmental agents with custom tools and instructions, plus whatever people built in Copilot Studio to patch gaps. Leadership keeps calling it one rollout. Operators start seeing it as multiple systems. The fifth signal is output quality drift that correlates with nothing obvious. Week 1, summaries are solid. Week 6, the same meeting format yields inconsistent action items. Week 10, citations shift. Week 14, users complain that it's not as good anymore, and nobody can tie it to a change ticket because the change wasn't a single thing. It was an accumulation, a model update, a Teams feature change, new content in SharePoint, a permission cleanup that removed something, a new channel created, a different meeting organizer, a different transcript quality, a different retrieval ranking. In deterministic SaaS, you'd isolate variables. In post-SaaS, variables are the runtime. And that's where MTTE becomes real, because the practical debugging question is not, is Copilot up? It's, what did Copilot see? Not what it could see, what it did see. What context it selected, what it ignored, and which tool calls it executed. Without that, you can't explain behavior. You can only argue about it. And the final entropy signal in Copilot is the slow collapse of shared assumptions. The organization thinks it has one assistant. In reality, it has multiple execution paths and multiple behavioral versions. Different teams start trusting different patterns, building different workarounds, and relying on different known good prompts that only work inside their slice of the tenant. That's micro-agent divergence, the same brand, the same license, the same platform, different behavior, different risks, different incident narratives. And once that divergence becomes normal, the next move is predictable. Makers step in to fix it. Scenario 2 setup, Power Platform agents at scale, and that's when the makers step in to fix it. Not because they're reckless, because they're useful. Power Platform exists to turn local pain into local solutions. And in the SaaS era, that was mostly fine. A flow that copies an attachment, a form that standardizes intake, a little app that replaces a spreadsheet. You could call it sprawl, but it was legible sprawl. Apps and flows you could list, owners you could ping, environments you could lock down when someone finally complained. Agentic Power Platform changes the shape of that sprawl, because the Power Platform isn't just low-code automation anymore. It's a distribution channel for decision logic. Copilot Studio and Power Automate don't just help someone build a workflow. They help someone package reasoning, retrieval, and actions into a reusable capability that other humans will treat as the system. And the cost of doing that is low enough that it will happen everywhere. This is the uncomfortable truth. If you want to understand how fast an organization will scale agents, don't look at Azure, look at Power Platform. Azure is where teams build carefully. Power Platform is where teams build constantly. And the reason is simple. It sits at the intersection of 3 things enterprises can't control with policy docs: business urgency, permission convenience, and template gravity. Business urgency means the moment a team has a recurring annoyance, they don't open a project. They open a flow. They don't ask for a system change. They ask Copilot to draft something, route something, create something, notify someone. And when that something works once, the next move is predictable. Schedule it, trigger it, wrap it, turn it into an agent. Now it's no longer assistance, it's execution. Permission convenience is the part nobody likes talking about in architecture meetings. Connectors are power, delegated connectors are borrowed authority. And the platform is designed to make connecting easy because friction kills adoption. So a maker connects to SharePoint, Outlook, Teams, Dataverse, maybe an ERP, maybe a ticketing system, and now the flow has reach across systems that were previously separated by human effort. The flow becomes a cross-domain actor. Template gravity is why this scales without anyone intending it to. Power Platform is full of examples, starter kits, copy this and tweak it patterns. Copilot makes that even worse in a useful way because it reduces the work of copying to basically nothing. A team sees a working agent, forks it, changes a couple of prompts, swaps a connector, and now they have their own version. It looks like innovation. Architecturally, it's divergence with a smile. So scenario 2 starts the same way every time. A business unit gets excited about Copilot, hits a limitation, and then discovers they can build their own agent-like behavior in Power Automate and Copilot Studio. It starts as just a helper, something that drafts a response, summarizes a request, or triages an email. Then it becomes just a workflow, something that routes approvals, updates records, creates tasks, posts notifications. And then quietly it becomes business logic, because once the system can take an unstructured input, an email, a form, a chat message, interpret it, choose a path, and execute actions across systems, you've moved past automation. You've embedded decision pathways into the organization. This is where the ownership model breaks in a very specific way. Teams own outcomes. Nobody owns life cycles. A maker owns the flow. A manager owns the process. IT owns the platform. Security owns the policy. Compliance owns the audit. And the agent-like behavior sits across all of them. Prompt instructions in Copilot Studio, branching logic in Power Automate, data in Dataverse, EOS in connectors, context in SharePoint, notifications in Teams. So when it works, everyone claims value. When it fails, nobody owns the behavior. That's not a tooling flaw. That's the operating model mismatch showing up in the place where scale is easiest. And it produces a failure mode that looks different from Copilot variants. With Copilot, people argue about output quality and citations. With Power Platform agents, the system starts doing things in the background. It creates records, it sends emails, it triggers downstream processes, it touches systems of record. So the consequences aren't just Copilot answered weird. The consequences are side effects, duplicates in Dataverse, premature notifications, silent routing to the wrong queue, a connector that was authorized for convenience and now acts as an escalation path, an environment that got cloned and now runs the same flow with different secrets. A prompt tweak that changes which branch fires and nobody realizes until 3 weeks later. And because the platform makes building easy, the organization will build faster than it can observe. That's the entire setup for scenario 2. Low friction creation of agent-like behavior in the one place enterprises already struggle to keep legible. What follows is the real entropy signal. It isn't shadow IT, it's shadow cognition. Scenario 2, entropy signals. From shadow IT to shadow cognition. Shadow IT was annoying, but it was visible. Someone spun up an unsanctioned app. Someone moved files into Dropbox. Someone paid for a tool with a credit card. You could discover it, block it, or at least name it. Shadow cognition is worse because it doesn't look like a thing. It looks like a reasonable workflow that happens to contain decision logic nobody can fully see, version, or test. The first entropy signal is where the logic actually lives. In Power Platform agent scenarios, the business logic is no longer just in a flow definition you can export and review. It's split across 4 layers. Natural language instructions, connector configuration, data shape, and branching behavior. The instructions in Copilot Studio become the decision policy, the connector becomes the authority boundary, Dataverse becomes the memory and state, and the flow becomes the execution engine that turns a judgment into side effects. That fragmentation matters because you can't review the agent as a single artifact anymore. You can review a flow, you can review a DLP policy, you can review a connector, but the behavior is the composite, and composites are where audit narratives go to die. The second signal is drift vectors that have nothing to do with someone changing the process. Connector auth changes. Someone re-authenticates with a different account because the original owner left. A token scope changes. A conditional access rule gets tightened. A premium connector gets swapped for a non-premium one to avoid licensing friction. Suddenly, the same agent takes a different path. Not because logic changed, but because reachable capabilities changed. Environment moves are another drift vector. Makers clone environments, copy solutions, migrate flows, and bring along just enough configuration to make it run. The flow still says production, but the secrets, endpoints, or connection references aren't the same. So behavior diverges while the artifact looks identical. Schema drift is the quiet killer. A column gets renamed, a choice value changes, a table gets extended, a view gets filtered differently. The agent still works, but it now grounds decisions on slightly different data. And because the decision layer is probabilistic, you don't get a clean error. You get subtly wrong outcomes that only show up weeks later as operational friction. And then there's prompt drift, which is basically configuration drift with better PR. A maker tweaks instructions because the agent felt too verbose. Someone adds a guardrail sentence, someone copies the agent and customizes it for their team. Now the organization has multiple cognitive variants of the same workflow, same name, same intent, different reasoning. You have forked brains. The third signal is the audit gap. Most organizations can see that a flow ran. They can see inputs and outputs. They can see which connector call happened. That sounds sufficient until the incident question becomes, why did it choose that branch? Why did it mark this request as urgent? Why did it notify that group? Why did it open a ticket instead of asking for clarification? Why did it write to Dataverse before approval? The flow log can show what happened. It cannot show the internal decision path that produced, therefore do X, because that decision path is embedded in a probabilistic layer with context selection and instruction interpretation. So you can prove that the system executed. You can't prove why it executed that way. That's shadow cognition. Decision-making that affects systems of record but can't be reconstructed in human terms fast enough to be safe. The fourth signal is behavioral side effects that look like data quality issues, but are actually decision pathway issues. Duplicate records are the classic one. The agent interprets two similar emails as two distinct requests, triggers the same flow twice, creates two cases, and now humans spend hours reconciling. Premature notifications are another. The agent decides it has enough context to alert stakeholders, but it's wrong. And now the organization burns credibility. Silent permission escalation is the most uncomfortable. Delegated connectors run under a service identity that has broader reach than the initiating user understands, so the agent can move data or trigger actions that feel like privilege creep, even if nothing malicious happened. The fifth signal is MTT spiking into permanence. Debugging stops being engineering and becomes archaeology. You're not tracing one system. You're correlating Copilot Studio instructions, flow history, connector auth context, environment configuration, Dataverse state, and whatever prompt changes someone made last month because it worked better. You ask who owns it and you get 3 names. You ask who can change it and you get 6. You ask what version is running and you get silence. And then the most predictable outcome happens. The business doesn't stop. They can't, so they patch again. Another flow, another exception, another connector, another tweak. That's the loop. Shadow it created unapproved tools. Shadow cognition creates unowned decisions. And once unowned decisions can execute side effects, you're no longer scaling productivity, you're scaling ambiguity. Scenario 3, setup. Azure AI orchestration without a control plane. Shadow cognition is what happens when makers distribute decision logic faster than anyone can see it. Scenario 3 is what happens when engineers do the same thing but with better tooling and higher blast radius. This is where Azure shows up in the story and the comforting myth returns. At least the pro-code teams will do it properly. They won't. They'll do it efficiently. They'll do it under pressure. They'll do it in fragments. And then they'll move on to the next backlog item while the fragments stay behind as permanent infrastructure. Because Azure AI orchestration isn't one product. It's an assembly line, a model endpoint, a tool layer, some retrieval, a queue, a worker, a database for state, a memory store, a set of retries, some temporary glue to connect a system of record. A dashboard maybe, a tracing setup hopefully, and a dozen small decisions about identity, secrets, networking, and logging that determine whether this thing is an engineered system or a probabilistic pile of side effects. Most organizations start scenario 3 the same way. A team gets asked to build an agent that does something real, not summarize documents, something with consequences, create tickets, update records, trigger approvals, triage incidents, draft customer responses, and push them into a CRM. The exact use case doesn't matter. The pattern does. It starts as an experiment because everything starts as an experiment. So they spin up an Azure OpenAI deployment or use Foundry or whatever their internal standard is this quarter. They add a little RAG. They wire up a few tools, they test it with happy path prompts. It looks good in a demo. Leadership sees the demo and thinks the hard part is done. The hard part hasn't started. Because the system that demos well is almost never the system that survives production reality. Partial failures, inconsistent inputs, permission edges, rate limits, downstream API quirks, and the simple fact that human workflows are messy and rarely match the data model. So the team adds orchestration, not because they love architecture, because they need the agent to do multiple steps reliably. And this is where the entropy begins. Each project invents orchestration from scratch. One team builds a state machine in code. Another uses durable functions. Another uses logic apps for steps and a custom worker for reasoning. Another uses queues and retries and calls it event-driven. Another uses a framework and assumes the framework is the architecture. Another uses a notebook that becomes a scheduled job that becomes a production dependency because nobody had time to rewrite it. Same outcome, bespoke state, bespoke memory, bespoke logging. It's not malicious, it's normal. And because every team has slightly different skills and slightly different constraints, they pick different building blocks, different storage, different telemetry, different auth strategies, different ways to do tool calling, different ways to handle human in the loop, different ways to package prompts, different ways to version anything at all. So the enterprise doesn't get an agent platform. It gets multiple orchestration dialects that can't explain each other. This is the part nobody says out loud in architecture reviews. Orchestration logic becomes the new integration layer, and integration layers are where enterprises accumulate their worst legacy, not because the code is old, because the dependency density becomes untouchable. Then the second predictable thing happens, prototype gravity. A proof of concept gets used just for a pilot. Then the pilot gets used just for this one team. Then the team depends on it for a quarterly process, then monthly, then daily, and now the agent is part of the operating model. But it still runs on POC assumptions, weak versioning, informal ownership, missing kill switches, inconsistent tracing, and an identity model that looks fine until it has to touch a system of record at scale. At this point, the architecture diagram stops representing reality, because the diagram shows components and arrows. The runtime is decisions and side effects. And when a probabilistic system executes, the most important details are the ones diagrams don't capture. Which tool was selected, what context was retrieved, which retries happened, what partial execution occurred, which compensations ran, and what authority the agent carried when it acted. Without a control plane, none of that is consistently captured. So every incident becomes bespoke. Every post-mortem becomes a debate about whether the agent did something wrong, or whether the downstream system behaved strangely, or whether the input was ambiguous, or whether the model update changed behavior. All of those can be true. That's the point. In scenario 3, Azure doesn't just amplify the agent problem, it industrializes it. Because now the organization can build agents that run continuously at scale across many systems with autonomous retries and delegation chains and tool catalogs that evolve faster than any centralized document can track. And if there's no control plane, no enforced identity, no consistent telemetry, no lifecycle ownership, no single place where tool authorization and version responsibility are anchored, you don't have an agent estate. You have a fleet of unsupervised workflows pretending to be software. Next comes the uncomfortable part. When orchestration becomes the new legacy, it fails in a very specific way. It doesn't crash, it leaves side effects. Scenario 3, entropy signals. Orchestration logic becomes the new legacy. The entropy signals in Azure orchestration don't show up as AI problems, and they show up as software problems that don't behave like software anymore. The first signal is that orchestration becomes the hidden monolith, not because the codebase is huge, because the dependency density is. One agent now depends on model deployments, prompt variants, tool schemas, secrets, queues, state stores, retrieval indexes, downstream APIs, and whatever retry policy someone chose at 2 a.m. during the pilot. Each dependency is reasonable on its own. Together, they form a system no one can safely change without breaking something they can't see. So the system keeps running, and it keeps accreting. That's how legacy is born in the cloud, not by age, but by accumulated reluctance to touch it. The second signal is the partial execution failure mode. Deterministic workflows usually fail cleanly. The transaction rolls back, the job errors out, the process stops. You get a single failure point. You know where to look. Agent orchestration fails like a distributed set of side effects. A tool call succeeds, the next one times out, retries fire, compensations don't. And now the system has done some of the work with no coherent boundary around what's complete. It created a ticket but didn't notify. It sent the email but didn't update the record. It updated the record twice because the retry logic didn't understand idempotency. Nothing is down. But the business state is wrong, and because it's wrong in small ways, it doesn't trip alarms. It trips humans. That's where MTTE gets paid again, not explaining an outage, explaining a trail of half actions. The third signal is that retries become policy decisions. In classic systems, retry logic is mostly technical, exponential backoff, circuit breakers, dead letter queues. Boring, fine. In orchestration systems, retries become behavioral governance, whether you admit it or not. Do you retry an action that sends an email? Do you retry something that creates a record? Do you retry something that triggers a payment or changes a permission or posts into a channel that people act on? Every retry risks duplicating a side effect. Every don't retry risks abandoning a workflow mid-flight. So engineers end up encoding business policy into technical defaults because there is no separate layer where those decisions live. That's entropy, when policy migrates into the least reviewed code path. The fourth signal is tool call reliability turning into a lottery. Every tool is available until it isn't. Graph throttles. APIs change. A connector version shifts. A downstream system enforces a new validation rule. A key rotates, a permission gets removed. The orchestrator still plans as if the tool exists because the catalog says it does. But runtime reality disagrees, so the system adapts. And adapts is the dangerous word here because adaptation without constraints is just improvisation with production data. One agent falls back to a different source. Another changes the order of operations. Another asks the user for input in one channel and proceeds without input in another. Over time, the behavior becomes a statistical distribution, not a designed flow. Again, nothing is down, but outcomes drift. The fifth signal is delegation chain blast radius. Teams love multi-agent patterns because they look clean on paper. Specialize the agents, delegate the tasks, keep prompts small, keep responsibilities clear. In production, delegation chains are how you lose accountability. A parent agent delegates to a retrieval agent, which delegates to a data agent, which calls an MCP server, which calls an internal API, which triggers an event that wakes a worker that runs another tool call. At the end of that chain, a side effect lands in a system of record. And the only useful question is, whose authority was that? Most stacks can't answer it cleanly. They can tell you which service principal executed the call. They can't tell you which decision pathway authorized it, which context justified it, and which human intent it traces back to because the chain is assembled dynamically. So you end up with a system that is auditable in the shallow sense, logs exist, but illegible in the operational sense, meaning can't be reconstructed quickly enough to matter. The sixth signal is telemetry that exists but doesn't compile into explanation. Teams will instrument, they'll add open telemetry, they'll capture traces, they'll log prompts, they'll store outputs, they'll have dashboards. And still, in the incident, someone asks the question that matters. Why did it choose that tool in that order with that authority given that context? And the traces don't answer it because tracing tells you what happened. It doesn't tell you what the system believed when it happened, or what it ignored, or what it couldn't see, or which version of the reasoning instructions it was operating under. That's the real entropy signal in scenario 3. Orchestration logic becomes the new legacy because it accumulates decisions faster than your organization can keep them legible. It doesn't crash, it corrodes. And once it corrodes, the enterprise does what it always does. It blames the platform. But the platform did exactly what it was designed to do. It executed. The reveal. Entropy is an operating model failure, not a platform failure. Here's what always happens next. The organization blames the platform. Copilot is unreliable. Power Platform is the Wild West. Azure is too flexible. MCP is another thing to govern. Foundry is moving too fast. The vendor narrative is tempting because it gives leadership a clean scapegoat. The tooling created the chaos, therefore better tooling will remove it. It won't. Because the platform didn't create the entropy, the organization did, by deploying probabilistic execution into an operating model designed for deterministic systems. That distinction matters. Microsoft platforms behave predictably, not in the nothing changes sense, in the system sense. They do exactly what they are designed to do. They expose capability, they reduce friction, they enable delegation, they let teams compose solutions locally, and they keep running even when no one is watching. That isn't a flaw, that's the product. The failure is that enterprises keep treating agent systems like feature rollouts when they are actually operating model changes. A new execution layer doesn't fit inside the old accountability model. It breaks it. In deterministic SaaS, responsibility is easy to assign. IT owns the service configuration, security owns policy, the business owns process, support owns incidents, vendors own uptime. And most of the time, that mapping works because execution is bounded. Users click, systems run, logs tell a coherent story. In post-SaaS, execution is not bounded by the UI. Execution is bounded by whatever tools are reachable, whatever context is selectable, and whatever authority the agent can present when it acts. Those are not settings, they're decision rights. And most enterprises have never explicitly designed decision rights for non-human actors. So you get the predictable failure mode. Everyone owns a slice, nobody owns the behavior. The business unit says, we own the outcome. Azure says, we own the platform. Security says, we set the policies. The makers say, we built the flow. Developers say, we shipped the API. And the agent sits across all of them, making runtime choices that no single team is accountable for explaining end to end. That's not a tooling gap. That's an operating model with a missing role. Someone has to own behavior, not just resources. Now, most leaders respond with the word governance. And then they do the thing enterprises always do when reality gets messy. They schedule meetings. Committees, review boards, intake forms, approval workflows, centers of excellence, quarterly check-ins, a big spreadsheet where someone tries to list every agent, every flow, every connector, every prompt library, every plugin, every experiment. That approach fails for a simple reason. Decisions happen at runtime. A meeting cannot govern a decision the system already executed. A policy doc cannot constrain a tool call the agent can still reach. A review board cannot keep up with prompt drift that spreads in a Teams chat in an afternoon. So the reveal is blunt. The organization thinks it has a governance problem. It actually has a contract problem. Agentic systems need explicit contracts, what the agent is allowed to decide, what it is not allowed to decide, what tools it can call, what data it can ground on, what identity it must use, what telemetry it must emit, and what constitutes a recoverable failure versus a business impacting side effect. Without those contracts, you don't have AI adoption. You have conditional chaos. And the most uncomfortable part is this. The platform can't solve that for you because it's not a product decision. It's an organizational decision. It's the definition of intent enforced by design. The platform will happily give you more capability, more connectors, more models, more orchestration patterns, more automation surfaces. That's not the problem. The problem is that you're scaling execution without scaling accountability for decision pathways. You're giving the enterprise a second workforce, an agent workforce, without redefining how work gets authorized, observed, and retired. So when leaders ask, why is entropy increasing? The answer is simple, because you tried to run probabilistic systems with a deterministic operating model. You kept ownership at the resource layer, and you left behavior unowned. And that's why entropy keeps winning. It has no counterforce. The way out is not more tooling. It's a design discipline. Agent-first architecture, explicit boundaries for probabilistic systems, where reasoning stays conditional, but execution stays deterministic, legible, and owned. Agent-first architecture, explicit boundaries for probabilistic systems. Agent-first architecture is not a new diagram style. It's a discipline for keeping probabilistic reasoning from infecting deterministic execution. Most organizations invert it by accident. They let the agent reason, choose tools, execute actions, and then they ask humans to review outcomes after the fact. That is not human in the loop. That's human as auditor. And auditors don't prevent side effects. They just write reports about them. The core principle is simple. Probabilistic reasoning must wrap deterministic execution, never the reverse. Reasoning can propose, reasoning can rank, reasoning can draft, reasoning can ask for missing context. Execution must be constrained. Execution must have contracts. Execution must be legible. If an agent can trigger an external side effect, then the system must force that side effect through a deterministic boundary that enforces assumptions, identity, authorization, idempotency, approvals, and telemetry. That boundary is where the enterprise stops improvisation. This is where most people misunderstand what agents are doing. They think the agent is the worker. Architecturally, the agent is the planner. The worker is your existing automation layer. APIs, workflows, queues, transactional systems, and the parts of the platform that already know how to do reliable work. The agent should not replace those. It should call them through a controlled interface with narrow capabilities. So the first design move is separation of agent types. Task agents versus decision agents. Task agents operate inside a deterministic envelope. Collect these inputs, fill this template, open this ticket, post this summary, schedule this meeting. Their decisions are bounded and their actions are reversible or at least compensatable. Decision agents are different. They decide what should happen, not just how to do it. They classify urgency. They choose who gets notified. They decide when to escalate. They choose between competing workflows. They are a policy surface. And that means you can't casually mix them. If the same agent both decides and acts, it will eventually act on a decision you can't defend. Not because it's evil, because it's operating on incomplete context, changing context, and shifting tool availability. Over time, it becomes a probabilistic policy engine with production permissions. So agent-first architecture forbids a common anti-pattern. One smart agent that does the whole thing. Instead, it forces explicit handoffs. A decision agent can propose an action plan with confidence scores and rationale. A task agent can execute steps only when given a signed, deterministic instruction set. A separate policy boundary can enforce whether the plan is allowed at all. That separation sounds bureaucratic until you've lived through a side effect incident where nobody can answer the only question that matters: who authorized this? The second design move is treating human in the loop as a boundary condition, not a checkbox. Human in the loop is not someone can stop it if they notice. It is an architectural gate where the system must pause, present the decision context, and require an explicit authorization to proceed. That gate should trigger on risk, not on vibes. Sensitive data access, external sharing, financial transactions, permission changes, customer-facing communications, or any action that can't be undone cheaply. And when a human approves, that approval becomes part of the execution record. Not a Teams message, not a meeting note, a first-class artifact tied to the agent identity and the tool call. The third design move is legibility as a non-negotiable requirement. Most leaders treat explainability like a compliance slogan. Agent-first architecture treats it as a scaling constraint. If the organization cannot reconstruct the decision path quickly, inputs, selected context, selected tools, prompt or version, identity used, and resulting side effects, then the organization is not allowed to scale that agent beyond a small blast radius. Legibility is not a nice to have. It is the only antidote to MTTE. And this is where the post-SaaS paradox finally gets a counterforce. Entropy grows when decision pathways multiply faster than explanation. So you design for explanation first. You don't ask, can we build this agent? You ask, can we explain this agent under pressure during an incident to security, to audit, and to the business owner who just got burned? If the answer is no, then it's not an agent. It's a liability with a chat interface. The final design move is to formalize boundaries as contracts. Tool contracts. What is scalable, with what parameters, with what scopes. Data contracts. What sources are allowed, what labels are required, what grounding rules apply. Behavior contracts. What the agent is allowed to decide and what it must escalate. Lifecycle contracts. Who owns versions? Who owns deprecation? Who owns the kill switch? This is how agent-first architecture turns AI strategy back into architecture, not by slowing down intelligence, by forcing intelligence to operate inside boundaries that remain deterministic, enforceable, and legible at scale. And once those boundaries exist, then you can talk about the thing most organizations skip, the control plane that enforces them. The agent control plane: identity, telemetry, lifecycle, and kill switches. At this point, most leaders hear control plane and their brain jumps to an admin portal. That's not what this is. A control plane is not a UI. It's an enforcement layer for assumptions: identity, authorization, observability, and lifecycle. The system either has that layer or it slowly devolves into conditional chaos with nicer branding. In deterministic SaaS, the control plane lived in the service itself. Exchange Online had admin boundaries. SharePoint had admin boundaries. The workload owned its own behavior surface, and your job was to configure it. In post-SaaS, behavior sits above workloads. It sits in orchestration, agents selecting tools, selecting context, delegating tasks, and executing side effects. So the control plane has to move upstack too, and it has to be boring on purpose. The first requirement is agent identity, not the maker who built it, not the user who clicked it, the agent itself. If an agent can act, it needs a first-class principal with a stable identity that survives org charts, team reorganizations, and the inevitable "this started as a pilot." That identity needs ownership metadata: who is accountable, what business process it supports, what environments it's allowed to run in, and what category of authority it holds. Without that, you can't do least privilege. You can only do optimism, because least privilege is not a philosophical stance. It's an authorization graph. If you can't point to an agent as an actor, you can't draw the graph. You can't review it. You can't revoke it cleanly. You can't even explain what happened when it does something expensive. The second requirement is tool authorization as a contract, not a convenience. Most organizations let tool reachability emerge organically. Connectors added, plugins enabled, graph permissions granted, and then everything gets called integration. That's how you build an accidental superuser. The control plane needs a capability catalog. These are the tools this agent can call. These are the operations exposed. These are the scopes. These are the data classifications allowed. And these are the conditions under which the call is permitted. If you can't express that in a machine enforceable way, then the agent is not integrated, it's armed. The third requirement is telemetry that answers the questions people actually ask during incidents, not did it run, who acted, on what, using which identity, with which authority, based on what retrieved context, through which tool calls, in what sequence, with what fallbacks, and what side effects landed in which systems of record. That's the minimum. Anything less is performative observability. And this is also where the industry keeps lying to itself with dashboards. Dashboards are summaries, incidents are specifics. You need event-grade traces that can be stitched into a narrative at human speed. If the only thing you can produce is a chat transcript, you don't have observability, you have theater. The fourth requirement is lifecycle management, because Entropy loves abandoned artifacts. Agents are not set and forget. Prompts drift. Tools change. Connectors rotate. Models update. Data sources get cleaned up. People leave. The agent keeps executing anyway because the system does not care about your org structure. So the control plane needs explicit version ownership and decommissioning. Every agent needs a named owner, a versioning scheme, a change log, and a retirement path. And owner can't mean the last person who touched it. It has to mean accountable for behavior and side effects. Otherwise, your agent estate becomes a museum of half-owned automation. And then finally, kill switches. Not as a last resort security fantasy, as an architectural primitive. If an agent can execute side effects, you must be able to pause it, revoke its tool access, or force it into a safe mode without redeploying half your environment. And you need escalation paths that are defined before the incident, not negotiated during it. Because the incident you're trying to prevent is not an outage. It's an agent doing the wrong thing quickly, repeatedly across multiple systems, while everyone argues about whether it was expected behavior. A real control plane makes that argument irrelevant. It enforces intent at runtime. And here's the uncomfortable truth. Once you have identity, tool contracts, telemetry, lifecycle, and kill switches, you've built the thing most AI strategies quietly avoid. You've made agents operationally legible, which means you can finally scale them without scaling ambiguity. Now the next question becomes obvious. If tool sprawl is one of the fastest entropy surfaces, what happens when MCP makes tool integration dramatically easier? MCP is integration relief and a new entropy surface if unmanaged. MCP is going to sound like the part of this story where the clouds part and the architecture gets easier. Because, mechanically, it does. The integration problem in the agent era is brutal. Every agent wants to call tools, every tool has an API, every API has an auth model, and every team wires it differently. That creates the classic MXN mess. You end up with bespoke connectors, brittle adapters, duplicated wrappers, and a constant tax every time anything changes. MCP's promise is to collapse that mess into something more linear. One side speaks agent, the other side speaks tool. The protocol becomes the contract, discovery, schemas, and a standard way to call capabilities. So instead of building 10 different custom integrations for 10 different copilots, you build or adopt an MCP server once and any MCP-capable agent can use it. That's real relief. It reduces the integration surface area you have to handcraft. It reduces the number of places where tool calling gets implemented poorly. And it makes tool reuse realistic, which is the difference between an agent program and 1,000 snowflakes. But here's what most people miss. MCP doesn't remove complexity. It relocates it into the one place enterprises are already failing to control: capability sprawl. MCP turns tool exposure into something that can scale as fast as copying a config file. That's the upside. It's also the failure mode, because once integration becomes easy, the default organizational behavior becomes expose one more tool, add one more server, publish one more capability, let one more agent use it. We can always tighten it later. You won't. That distinction matters. In architectural terms, MCP is not an integration convenience. It is a tool distribution system, and every distribution system becomes an entropy accelerator unless you force contracts around what gets distributed, who can publish it, and what safe to consume actually means. So MCP introduces a new entropy surface, standardized tool sprawl. Before MCP, tool sprawl was slowed by friction. Every integration required effort, which acted like a crude control. With MCP, the friction drops, so the sprawl becomes limited only by imagination and urgency. That's not a moral critique, it's system behavior. The first risk is server registration becoming an accidental marketplace. Teams stand up MCP servers for their own needs: a Jira server, a ServiceNow server, a CRM server, an internal data server. Each one exposes a slightly different schema, different naming, different guardrails, and different assumptions about authentication. Then agents discover them, and now the enterprise has created an internal app store for capabilities, without the review rigor that app stores evolved to require. The second risk is capability catalogs drifting away from least privilege. Tools are never neutral. A tool is authority packaged as an API. If a tool can create a ticket, send an email, update a record, or change access, then exposing that tool through MCP isn't integration, it's delegation. So the question isn't, can the agent call the tool? It's under what identity, with what scopes, with what constraints, and with what audit narrative. If MCP makes it easy to call tools, it also makes it easy to call the wrong tools with the wrong authority, especially when teams treat servers as shared utilities instead of controlled boundaries. The third risk is change management collapsing into surprise. MCP supports dynamic discovery. That's the feature. Agents can learn what tools exist without hard coding. But dynamic discovery without change control is how you turn production behavior into a moving target. A server adds a new capability. A schema changes, a parameter meaning shifts, an auth requirement changes. The agent doesn't break in a neat way. It adapts, it selects different actions. It fails over. It produces different side effects. And your MTTE spikes because the execution path changed without a deployment event you can point to. That's the paradox again. Interoperability increases the need for contracts, not less. So if an organization adopts MCP as integration relief, but doesn't treat MCP servers as first-class production surfaces, versioned, owned, restricted, observable, then MCP becomes the fastest way to industrialize conditional chaos. This is why the agent control plane matters even more once MCP shows up. You need enforced server registration rules. What qualifies as publishable, who approves, and what metadata must exist. You need capability classification. Read-only tools versus side effect tools versus privileged tools. You need identity boundaries, which agents can call which servers, and whether those calls are on behalf of a user or under a service principal. And you need change discipline. Versioning, deprecation, and explicit compatibility promises, because otherwise every small improvement is a behavioral drift event. MCP can absolutely reduce integration debt, but it will also let you scale bad integration faster than you ever could before. The protocol isn't your safety net, it's your multiplier. And once you accept that, the next move is obvious. Don't scale agents first. Scale legibility first. Which is why the only sane way forward is a controlled pilot that proves you can explain behavior before you amplify it. The 90-day agent-first pilot, prove legibility before scale. The worst way to respond to all of this is to announce an agent program and then let every team build whatever they want, faster, because the board is excited. That just turns entropy into a KPI. The only sane move is a 90-day pilot that proves one thing before you scale anything. The organization can explain agent behavior under pressure. not in a demo. In a messy week, with real inputs, with real side effects, with real stakeholders who get angry when the system improvises. So pick one cross-functional process with consequences, not drafting content, not summarize meetings. Pick something that touches a system of record and triggers downstream work. Onboarding, access requests, supplier onboarding, service triage, invoice exceptions. Something where the organization already knows what wrong looks like. Then design the agents like products, not helpers. That means you name an owner who owns behavior, not just the repo. You give it a backlog, versions, a deprecation plan, and a defined blast radius. You decide what production means for this agent. You decide who can change it. And you decide how change gets reviewed. Because prompt edits are still logic edits, even when they look like English. Now you establish the boundaries, the pilot exists to validate. The deterministic core comes first. The workflow steps that must be correct, auditable, and idempotent. The things that create records, update fields, send external messages, or change access. Then you wrap that deterministic core with probabilistic reasoning. Classification, extraction from messy inputs, drafting, summarization, prioritization, and recommendations. Reasoning can propose actions. It can't execute side effects directly. It must call the deterministic layer through explicit tool contracts. And you don't let the pilot cheat. If the agent needs a tool, you register the tool. If it needs data, you define which sources are allowed. If it needs authority, you assign an identity and scope it. If it needs to escalate, you define a human gate with a named approver and a clear stop condition. This is also where you design for failure as a first-class feature. Agents will hit ambiguous inputs, downstream APIs will throttle, a connector will fail, a human will ignore an approval request, a model update will change behavior slightly. None of that is surprising. What matters is whether the system fails legibly. So your pilot needs two kill switches, one to pause the agent, and one to force safe mode where it can only draft and recommend, not act. And those switches can't be buried in a runbook. They have to be operational muscle memory. Now measure it, not vanity metrics like prompts per user. Measure the entropy signals this episode is built on before and after. Mean time to explain is the headline metric. How long it takes to answer why did it do that with a coherent narrative and evidence. If MTTE drops, you're building a system you can scale. If MTTE stays high, you're building a mystery generator. Track incident ambiguity. How many incidents involve behavior drift instead of outages? Track drift frequency. How often prompts, tools, or connectors change without a corresponding change record tied to the agent product. Track agent-to-human ratio inside the pilot, not as a brag, as a budget conversation. If one agent produces 1,000 decisions a day, then you just created a new operational workload, whether you planned it or not, and then do the part most pilots avoid. Prove decommissioning. At day 90, you either promote it with stronger boundaries or you retire it. That retirement must revoke identity, disconnect tools, archive traces, and remove it from discoverability. If the organization can't cleanly kill an agent, it can't claim it controls agents. It just accumulates them. The output of this pilot isn't a slide deck. It's a repeatable pattern, a reference architecture, a decision rights model, and a telemetry story that compiles into explanation. That's what scale actually requires. Conclusion: AI doesn't reduce complexity. It converts visible systems into invisible behavior, and invisible behavior is where architectural entropy multiplies. If this matched what you're seeing, leave a quick review with the worst mean time to explain story you've lived through and connect with Mirko Peters on LinkedIn. Send examples so the next episode dissects real failures.